Hi, my name is Krsna and this is my video presentation for CSC2230 Big Data Management and Analytics. The Instacart dataset which I analyzed was shared in 2017 and contains over 3.4 million online orders from more than 206,000 users. The primary purpose of this dataset is to provide a real-world, large-scale transactional database that allows for in-depth retail analytics and demand forecasting. Its intended use was for the Kaggle market basket analysis competition, where users were challenged to build recommendation systems which predicted which products a customer would add next to their cart. Structurally, the database uses a highly relational model, comprising files for departments, aisles, products, orders, and a transactional bridge, the order products table. From a privacy perspective, all user information is anonymized, and temporal data is represented as relative integers, with data minimization principles applied to strip all unnecessary information before analysis. To efficiently manage this volume, I designed a robust data pipeline. I utilized a cloud-based SQL environment in Google Colab with Python's SQLite 3 library. My ETL or extract, transform, and load pipeline was built using the Pandas library, and because of the dataset size, I implemented a system so that the data was imported in chunks of 100,000 rows to prevent system memory crashes. Furthermore, my design enforced strict data integrity through primary and foreign keys, ensuring that we are always analyzing clean, consistent business data, which is further discussed in my report. Now, moving on to the technical execution. To demonstrate how we extracted our business insights, let's look at Query 1, which identifies the most frequently ordered products on the platform. To execute this, we use a select statement paired with a count aggregate function. Because our data is relational, we use a join clause to bridge the raw receipt data in the order products table with the human readable names in the products table. We then group by the product name and order by the total purchases in descending order. When we execute this query, Pandas renders our data frame. As we can see right here in the live output, everyday fresh produce entirely dominates the top of the list, with bananas and strawberries taking the highest rankings. This specific output leads perfectly into the broader macro-level trends we discovered across all of our SQL queries. When looking at all of our SQL findings, several clear trends emerge. Firstly, regarding product popularity, and as mentioned before, produce items, specifically bananas, strawberries, and avocados, had dominated the top rankings. This finding is consistent across our reorder analysis in Query 4, where organic items were also the most frequently reordered. When investigating the departments, produce was the most popular category and fresh fruits was the most popular aisle. And when analyzing customer behavior over time, it revealed that orders peaked on the weekend, with roughly a 10 to 20% increase compared to weekdays. In addition to this, most orders occurred during daytime hours, peaking consistently between 10 a.m. and 4 p.m., with a gradual decline throughout the evening. Our findings reflect some bigger picture and underlying findings. For starters, in terms of actual insight for our business, we can observe a perishability cycle. This is because fresh produce tends to spoil quickly and thus necessitates more frequent replenishment compared to staples such as flour or rice, which not only have longer shelf lives but larger and bulk pre-packaged portions, which means it takes longer for households to consume. Furthermore, our findings also suggest that for most, online grocery shopping was predominantly considered a daytime weekend activity often done around midday. To move forward, management should implement demand smoothing. This could include, for instance, mid-week incentives like reduced delivery fees, which can help distribute demand and reduce the weekend surge, which can help to create more consistent revenue, increase the time customers spend on the app, and potentially create more customers and orders. We should also prioritize cold chain logistics and ensure that fresh produce and dairy items are stocked optimally. Additionally, targeted marketing and cross-selling can also be implemented, which could recommend higher profit margin products and longer shelf life items or frequently forgotten products in order to increase revenue, improve customer satisfaction, and user experience. For Instacart specifically, we must also focus on gig worker incentives and surge pricing during weekend morning peaks to ensure enough personal shoppers are available, helping maximize revenue and reduce downtime. Finally, we must address data ethics. When using customer and business data, it is important that all personally identifiable information is tokenized and anonymized before reaching analytical teams, with access granted only to necessary personnel. In addition to this, organizations must ensure compliance with local governance guidelines regarding data protection. This includes regulations such as the Australian Privacy Principles and the European Union's GDPR, and by ensuring users are informed about data collection and have the right to request access to or the deletion of their data. Furthermore, when using algorithms for employee performance data, it is critical to use this data constructively, providing transparent explanations for performance ratings and providing accessible pathways for gig workers to dispute unfair ratings caused by real-world friction. By combining robust database management with critical business and ethical analysis, we can turn raw transactions into sustainable data-driven strategies. I appreciate your time and thank you for watching.